So I'm going to give you just an agenda of what I'm going to cover today. So the first is I'm going to give a little bit of background on just my journey at LeanDNA and my background. Then I want to spend a little bit of time talking about what we call the execution gap. And that's, my whole career has been in manufacturing, supply chain, and how do you bring technology together? And we've seen this kind of gap emerge, and I'm going to explain why it happens and what's driving it. Then the next year I'll talk about is what we call optimized execution. So it's like, how do we bring together some of the innovations around more advanced AI and analytics, combine that with what we're trying to do from an execution perspective? And how do we not only drive big gains, but what is that maturity curve in terms of what is a process you want to go about in terms of implementation? Then I want to spend some time actually hitting on some real AI use cases around manufacturing. So one area is called Plan for Every Part, PFEP. So a lot of that is about how do you get the inputs right and the data so you can actually drive better optimization within manufacturing. I'm then going to give you a little intro of what we call K, and K was actually named after one of my Japanese partners he worked with Shigeo Shingo over at JMA. He worked from Toyota, was kind of one of the early pioneers. He was the individual that actually trained me. So we have an AI that we've built that actually allows you to interact with data and ask questions, and it's trained on a lot of the analytics that we actually implement. Then I'll talk about the inventory action case study, and then another case study around predicting and managing supplier risk. Talk a little about the future, then open it up for some Q&A. But before I get started, just a quick, just to get a sense, how many people here are actually working in supply chain manufacturing, just to get an idea in supply chain? Okay. And I'm sure, have most of you all been exposed to like Chat GPT and, Claude and some of those LLMs? Okay. And just one last question. How many are actually kind of implementing these capabilities like from an AI within your company, especially the last 6 months or so, last year? Okay. Great. So hopefully this is helpful. Let me go back one. As Doug mentioned, my last 30 years I've been in manufacturing supply chain, but I had a computer science, mechanical engineering background. So my whole career was not only, fortunately, I got involved with lean manufacturing very early on, but my whole career is on how do you bring technology to bear to kind of make it like easy for people. I remember when I first was working with my Japanese partners and we're walking a factory and I was a typical American talking a lot, asking a lot of questions, and he kind of, I was probably in mid-20s and he kicked me and he said, you need to stop and look, right? And observe what's going on, which was a big, learning for me. But the second thing he talked about was lean was all about making work easy for people. So they didn't like using a lot of the Japanese words and, that we kind of embraced here in the US and Europe. They really were focused on keeping it simple. How do we make work easy for people? So what is happening around this whole area of AI is really just a huge opportunity to use technology to make work easy for people. And that's what's rather exciting. So I just have one or two slides on LeanDNA, just so you know who we are. I started the company. My last company was really focused on inside the factory and how do you improve efficiencies and how do you manage material within the four walls of a factory. And what happened for me after we were acquired by SAP is I started looking back at the market and what was happening. And what I could see was that lean was becoming very well established within the factory, flow lines, value stream, SMED, creating mixed model assembly lines. And I could see that it becoming like very efficient. I was working all over the world to help implement that. And one of the things that happened to me was we had spent, probably a year or two creating some very balanced, very efficient assembly lines for some aerospace companies. And whenever we had shortages though, all of a sudden we'd stop the line and squeaking out like 2 or 3 or 4% efficiency. And then all of a sudden we lose 30% because we don't have the right materials at the right time. So it kind of hit home with me that you need to start really attacking this whole material supply chain side much more heavily. And so where the manufacturing has really evolved, what we found was that the supply chain, especially what I would call factory-centric aspect of supply chain, which means really understanding what manufacturing is trying to do, especially a lean manufacturing operation, and then how does it connect with supply chain? It's a huge gap, very manual, spreadsheet based. And so that was what led me to start LeanDNA probably about 15 years ago. We're now in about 30 countries, 500 sites. We've integrated with about 40 different ERP systems. And our real focus is really empowering that kind of factory-centric supply chain to, improve on-time delivery by reducing critical shortages, to also at the same time reduce excess inventory. And as I mentioned earlier, it's like, how do you do both those things with less people? And that's really the goal. And as Doug mentioned about the internet, I was there, it speaks to our age, Doug, when we talk about the internet, and I was there when it first came out, and I haven't seen a lot of innovations over that time since then. I mean, a lot, but to me, what's happening with AI right now is pretty dramatic. I mean, I haven't seen anything like that, and we're actually really using it. We're building technology, and it's pretty exciting what's going on in terms of changing the way people work in the future. These are just who we work for. The only thing I was just going to mention, with a lot of these companies, that we're not like in one or two companies. We, like in Saffron, we're in about 65 of their sites. So we tend to go in to one or two sites, and our focus has always been show the value, get results, and then grow it from there. Johnson Controls in the industrial products area, we're in about 45 sites and about 1,000 suppliers. And that's pretty consistent with a lot of these companies. But the interesting thing for us, as I go through our presentation, was this really deep understanding of the needs in manufacturing, and then how do we now go ahead and connect that across the broader supply chain. And we had a few little technical things, but it looks like it's working well. Okay. So the first thing is just kind of where we are today in terms of the gap. So what I'm just trying to show you here is, if you look at the bottom, there really has been a lot of innovation around the areas like ERP and MRP. There's been a lot of innovation around inventory planning, demand planning. BI tools started to evolve, business intelligence, provided some really great analytics to help us with visibility. But if you look back, let's say 10, 15 years ago, whatever that gap was that those tools couldn't do, we could bridge it with the spreadsheet. I mean, I was great at creating macros, custom spreadsheets. But the challenge today is that when you think about the globalization of supply chain, when you start looking at the increase in this, what we call like mass customization, just more and more options, more variety, give our customers what they want. The whole area of like order online, what Amazon and these different technologies have done is everybody can go order what they want now with a lot of variety, but the manufacturing just haven't kept up. And so that's where we've seen this gap where spreadsheets worked really well. Like I said, 10, 15 years ago, you could get by. More and more, we're finding companies just can't get by with that anymore. And so now they're looking for alternatives, and it's not just like BI around visibility, it's tools that can help us with workflow as well. So I spent a lot of time, because I remember, we're talking like 30 years ago doing different AME conferences, and we're always talking about, spreadsheets and how ERP means, I think Excel runs production, I think is the term that they were used. So spreadsheets have always been this kind of joke in a way, like, yeah, we bought all these systems and we're still running it in spreadsheets. So I tried to spend a little bit of time trying to think about a simple way to explain the why behind that, at least the way we view it. So when you think about, again, this kind of factory-centric supply chain, there's different roles, and sometimes they're using different terms, but there's like your typical production planner, scheduling production. There's a material buyer that's buying for the factory, and then there's a supplier. And so the good thing is there's actually been a lot of innovation, new technologies in a lot of those sectors. So if you think about production planning, SAP has evolved, Kinaxis, there's a lot of technologies that have evolved to make planning a lot easier. Then when you start looking at the supplier component, making supplier collaboration easier, sharing information, making it more digital, that's evolved as well. But when you think about the material buyer in a factory, that's kind of that area that we've seen has been left behind. It's still very spreadsheet based. So when you start thinking about that bullwhip effect, you kind of really, see it pretty, not only heavily, but you're seeing even more because of, I think, COVID, a lot of the disruptions over the last several years. You've seen it more and more where you start hearing about that bullwhip effect. I remember 4 or 5 years ago, I was driving to the office, and it was the first time ever, we were teaching this stuff 20, 30 years ago, and then I'm hearing about the bullwhip effect, the beer game, and this was on the National Public Radio. So more and more people are starting to realize it. So where we're really trying to target with a lot of the technology and the things I'll be talking about is how do you really empower that area of procurement within the factory and also empower that area of planning through things like what we call, I'll talk a little bit about what we call clear to build, which is the ability to look at order by order, understand what material is going to impact our ability to deliver, and really being able to prioritize what really matters for production readiness. So one area is how do you kind of manage that factor and prioritize to reduce critical shortages to improve on-time delivery. Then how do you now extend that to your suppliers? I'm sure many of you still hear and see a lot of that kind of whiplash that you're doing to your suppliers, where one week we're telling them to expedite, next week we're telling them to cancel, then 2 weeks later it's expedite again. At least from what we're seeing, and we're working with the biggest companies in the world, including like Ford Motor, and we're in there and it's still very similar, right? There's still a lot of, spreadsheets, a lot of old systems. So really attacking that both on the front end through things like clear to build and optimize the planning process, and then optimizing the way you connect are the two areas that we're really seeing as big opportunities. So the term I use that kind of describes the area that we're starting to really attack is what we call optimized execution. Some of the challenges that we run into when people buy like an SAP or an Oracle or Infor, any of the ERP systems, is the perception is that, well, I bought this, why doesn't it just work? And they're always struggling with this question is, why is my team doing so much in Excel when we bought these big ERP systems? And part of the reason is that you really need to think about whether it's kind of an execution or optimization. So a lot of what I would say exists with these ERP systems is they do a really good job when you talk about execution to some degree. But when you start thinking about the area of optimization, that's where there tends to be a bigger and bigger gap. And that's where a lot of what we're seeing with the more advanced AI that I'll talk about becomes pretty impactful. So like when I think about execution, a lot of what we target is how do you go connect to that ERP system and extract the right data? Then you move into things like what we call clear to build, line of balance, and that's really helping us prioritize shortages. And you'll hear me use that word a lot, prioritization, throughout the presentation, because that's what we think is like the big gap. It's not that the information doesn't exist. Like we're not necessarily creating new data. Now we may be logging data and creating more advanced analytics, but a lot of times the data exists. It's just how it's being used. So being able to connect with these systems and then have things like the line of balance clear to build that helps you prioritize is a big opportunity that we've seen around how do you actually reduce critical shortages and prioritize those. The next area is around like PFEP. And just a question, who does PFEP here? Heard that term, plan for every part, PFEP? Okay. So the way I would describe it is for any of this kind of AI or advanced analytics to work, you need to have data, right? Good data. And so plan for every part, PFEP would be things like, do you have the right safety stock? Do you have the right ordering policy? What's the target like cycle stock? And so there's a lot of advanced analytics that go into it, but if you don't have the right inputs, part of the issue that we see on the supplier collaboration side, on the supplier planning side, is that if you don't have the right inputs, everything else becomes harder. It's like having, building a house and your foundation is a little bit off. And then you're constantly struggling with doors not closing properly, the windows don't fit, things are, leaking. So PFEP is all about how do you get the foundation right? How do you get the right policies in place? And then ERP runs better, your planning process runs better, the ability to prioritize becomes easier. So I'll talk a little bit more about PFEP in a little bit, but that's where we've actually been applying a lot of the AI techniques, which is, helping get your safety stock, your order policies, the way you're actually going to procure and plan, get that to be a lot better. And then performance tracking is the next area. And so the key thing here is we take that understanding of execution, then we feed it into optimization. So we then try to set the right safety stock, set the right triggering quantity for a reorder point. What's the right Kanban sizing? And then once we do that optimization, we then feed it back into execution. And the important thing is we actually learn from execution. It's called reinforcement learning, where we made an assumption about safety stock. But then what we learned over time is that this part, part A and B look exactly the same. But part A, we're always running short. Part B, we never came close to safety stock. There's no data that would explain exactly why that happened, but we can actually learn over time based on different characteristics from the way different relationships, feed that back into optimization, and then do a better job in execution, okay? So more and more what we're seeing with some of these advanced technologies is starting to merge this area of execution together with optimization, and that's where you're seeing some big impacts, okay? Hopefully that makes sense. And I'll be giving some case studies in some of these different areas as I walk through it. The other thing that we noticed is, again, especially when you start talking about technology and how does technology work with your teams, it's very difficult to and it's a mistake just to do everything at once. So over the last 10 to 15 years, we started to see kind of a real pattern for how do you deploy technology in a way that kind of supports different levels of maturity, okay? And so I'll kind of walk you through at least the way we've seen it. And again, this is specifically to the area of supply chain. But the first area we typically like to attack is what we call tactical procurement. And so that gets into things like daily standard work for your buyer and establishing kind of a workbench. And again, ties to prioritization. The next area is around inventory action prioritization. So you're getting a lot of messages to pull in, push out, cancel. But what are the 10 or 15 actions that buyer should take today that could have the biggest impact on the business in terms of inventory and delivery? So being able to prioritize that is kind of the next step. And then obviously being able to manage shortages. So that's kind of that role of a buyer, like a material buyer, procurement member of your procurement team. Then there's the role of the analyst. And what I'll do is I build this out. I'll talk about the different roles that get added over time and the change in what each role does as you move forward. So the buyer, that's their function. The LeanDNA or the leader or the analyst would be around making sure you're compliant with your current order policies. Do you have the right safety stock? What does that burn-off projection look like? And then below, I just mentioned some of the things that we typically measure. Things like buyer engagement, engage inventory action buyers. And what that means is, it's not all about, from a technology, just people using it or logging in. What we spend a lot of time measuring is, are they doing exactly what we want them to do? And we call that like a workflow engaged buyer, a workflow engaged planner. And so what we've learned over time is that the more that we can establish standard work from a technology perspective and know exactly what we want them to do, and then measure that and then drive that engagement, we see a direct correlation with business results. Inventory, turns improve, or inventory days of supply reduces, shortages get reduced, service level improves. So direct correlation, if you can define that standard work, measure it, and you see that correlation with results. So that's the first area, is tactical procurement. Then we move into kind of what we call operational execution. That's where we introduce the role of the planner. So the way I view it is, the first thing is you got to get control of your materials, and that's kind of that buyer activity. Once you have good control and good optimization of your buying process, then you want to move into your planning process, and that's where we start to introduce things called clear to build, a typical line of balance, and that's the ability to look, like I said, order by order at every level of the BOM, whether it's make part or buy part, and look forward in time and predict and identify what material is going to impact our ability to ship over the next 2 weeks, 3 weeks, 4 weeks. Then engaging in collaboration between that planner and the buyer. And then we've also introduced something that we call shortage risk scoring. We were doing a lot of work in the aerospace sector, and Airbus had approached us because we do a lot of work with Safran, Bombardier, big companies. And one of the issues that Airbus, and for those of you in aerospace, you may have seen this, but they were doing this kind of risk scoring for every one of their kind of tier 1 level suppliers. And what that risk scoring had to do was look at every single part and look at different factors, from supplier performance, trend towards safety stock, characteristics of that part, demand variability, and generate a score that they could rank to identify what parts could have the biggest potential risk on Airbus to impact their ability to produce. And so all of that was very manual. It's spreadsheet-based, homegrown solutions. And so part of what we were able to do through AI and some of the newer technologies was to be able to automate that. And that's been a big impact. And so again, if you see a theme, like I said, it's all about prioritization. That's where we see a lot of advantages to the tool. So getting control of your buyer through tactical procurement or that process. Next stage is around operational execution, the planning process. And then with that information, you start to work with how do we communicate better with our suppliers. And there's a lot of portals that exist in supply chain, a lot of ways that data gets communicated. But again, the biggest issue we find is what are the priorities that matter around POs that need to be moved in or out? How do you get confirmation of those priorities? And then how do you feed it back into the planning process? How do you feed that back into, the procurement process? So this next stage starts to introduce that role of the planner, and how do you collaborate better between the supplier? How do you collaborate better between the planner and the buyer? And then the last piece is just around the automation. And that's where we start to do things like ERP write-back. So we're taking all this data, we're doing more optimization, we're monitoring execution, feeding that back into optimization, we're getting the order policies right. Now we want to feed that back into the ERP system so that it can actually perform better. So the good thing is with the technology these days, like I said, ERP is actually a really good system. It's not that it's bad, but it's really understand where is it great and where are the gaps and where are the weaknesses. So from a technology perspective, we spend a lot of time trying to understand where those gaps are, how to bridge those gaps. And then this is a good example where getting your order policy site, safety stock, trigger levels, ERP does not do that. I mean, we work with every major ERP system. When it does do it, it's usually some customization or it's pretty limited. But to do it right with a lot of kind of lean manufacturing methodology built in, it's pretty limited. But once you can follow this maturity curve and then get to the point where you're now, executing better, optimizing better, and then feeding that back into your ERP system, it's incredibly, incredibly powerful. And it also means your systems just run better naturally, right? So even, if you're using some sort of IBP, like integrated business planning process, just doing all these stages will actually make your ERP system work better. And so a lot of what I would say we suggest you do is take a look at this view, and I see some of you taking pictures, but take a look at this view and try to understand where you fit. But it is a journey. It's not something that, you're ever done. Just like Kaizen or any process, it's a continuous evolution. So I now wanted to just spend a little bit of time talking about, AI, and I'm going to for those of you that probably are working with it, some of this stuff may be things you already know, but I did want to introduce a few of the terms and the technologies and put a little bit of a supply chain lens on it. So you understand, because everybody's hearing about AI these days, but what does it really mean, from a supply chain perspective? That's kind of what I want to hit on. So the first is just kind of doing a quick summary on current state versus future state or with analytics. So if you look at the current state today, procurement teams spend a lot of time just collecting data, gathering information. We find that there's very limited standardized work. And a lot of times when you do it, it's still very people dependent. When that person leaves, a lot of times it could fall back. So that's a challenge. There's still a lot of BI tools, Excel, and BI is good, but our view of it is it's great. I mean, it's been great in terms of what it's done, but it creates a lot of visibility, but it's very limited in what it can do about driving action, driving execution. So again, great visibility, but still very manual when it comes to execution. And the results of that is you tend to still see a lot of emails, phone calls, daily stand-ups are great, but there tends to be too many of those type of meetings and things are very manual and repetitive. And so this is where we see things headed with advanced analytics is all the data is available. And I'll talk a little bit about this in terms of the case studies, but it's so easy now to get information. I'm talking in the last 6 months or a year. I mean, I've been in technology, software development for 30 years. I've never seen anything like what's going on even in the last year or so. It's amazing. So and the reason why I mention that is what I always encourage people that are in like operations that are the user of technology, you almost need to assume that anything's possible these days. I know it sounds kind of crazy, but that's the way I view, that's what I tell my team, assume everything's possible and then let people explain why it's not. And I wouldn't say that 2 or 3 years ago. I mean, we're doing things now where I would have put 3 developers, product team for a full year to build something. Now we have 1 or 2 people doing it in 2 or 3 weeks. I mean, that's the change. It's not a trivial evolution that's going on right now. It's rather dramatic. Work is more standardized. So, standardized workbenches, standardized process. And again, technology is a big driver in how do you make that happen? If you have standardized work, but your technology doesn't follow it, it's hard to maintain it. And so our view of it is if you can, standardize the work and then have technology follow it, it's very powerful. Better visibility for communication. And the other thing is what we call like unified, visibility across the different ERP systems or normalized data. So a lot of our customers have anywhere from, we have some companies that have 3 or 4 ERP systems. We have some that have 15 or 20. And it sounds crazy, but some of these big companies have just grown over time. And so they have a lot of different systems. Even if they have SAP, sometimes the way they use SAP is very different. So now the real strategy is how do we standardize and normalize that data? So when you feed that into any sort of AI technology or you're doing more advanced analytics, everything is more consistent. And what I would say is that that's become very, very easy now too. So just again, assume things are easy and let the technology people explain why it's so difficult, because a lot of times they just don't understand what we're trying to do from an operational perspective. So the question is like, why now? Like, why am I speaking on this? Why am I probably so excited about this area? Is that there's been some interesting innovations that have happened. The first one is just recent breakthroughs. So LLM, so that would be like the Chat GPT, Claude or Anthropic, Grok, different technologies. But more importantly, they understand the supply chain language and context. And I'll show you some examples of it. It's not just that they're LLM, but they're trained, they understand these concepts better than, a lot of people. So it doesn't mean that you can go to them for the answers, but when you want to interact with these systems and you start to connect them with data, it's really powerful what you can do. The AI models can now handle much more complex multivariable data. So there's a term called heuristic, and that heuristics in kind of analytics or modeling technology perspective. And heuristics are very kind of rule-based. And you can handle 2 or 3 and very limited number of parameters. But what you can do with the models is you can handle an enormous number of parameters, a lot more parameters than you could ever do before. The other thing that you can do is you can set models that are not just trying to drive to one result or 2 results. You can drive to a goal. So you can say, my goal with my planning process is to maximize revenue over the next 2 or 3 weeks. But I also want to keep my line running with the staffing of 80%. How do I best organize my line considering procurement, limitations, capacity? And now you can start to model this out in weeks with more out-of-the-box technology, where before you couldn't even do it. And if you did try to do it, you're talking 2 or 3 or 4 years. And so the advantage today is that companies that have spent years building this technology that's very proprietary, you're almost at a disadvantage than individuals like yourself that may be trying to go after it today. And let's see what's out of the box. There's technology out of the box now, things like TensorFlow, where you can do a lot more modeling very quickly than that just didn't exist a few years back. Cloud computing is a lot cheaper these days. And these models, when you do modeling, a lot of these models today are pre-trained on industrial data, right? So you don't have to start from scratch. It understands not only a lot of the concepts of supply chain, but there have already been models that are already pre-trained on very specific supply chain data. So one area is just the recent breakthroughs. The next area is, like I mentioned, is data availability. ERP is capturing a lot of rich data. Sensors, sources, you hear terms like IoT, connecting to machines, much better, much broader. Again, assume the data is available. More and more, I think over the next year or two, it's not going to be a matter of can you get the data, it's how do you effectively utilize it. Supplier collaboration is becoming easier, and that means that it's more digital now. So understanding supplier performance, collaborating around issues is a lot easier. And the last thing about data availability is just the ability to log data. So when I mentioned optimization and execution, why things like reinforcement learning are becoming more possible is the ability to just log massive amounts of data and then be able to analyze that data. So we're logging, all the analytics that we're capturing through our ERP systems and all the transactions. We log all of that every single day. We log information about user engagement and what they're doing. So now we're able to roll back and look at performance. What did we think was going to happen? What actually happened? Why did it happen? And all that data from a historical perspective is now logged. And so now you're able to use that in pretty innovative ways. And as you can imagine, there's a lot of competitive pressure right now where it's no longer who's first. It's like, who's last, because if you get left behind, it's going to become a real challenge. Now, what I love about manufacturing is that it's not just technology. It's people, it's machines, it's physical, it's real. And that's why I've always loved working in this area. But it is kind of, and we're hearing it from, from analysts, that it's kind of one of the last kind of green spaces or green places where people haven't really gone after yet. So it's kind of one of these future opportunities where we think there's a lot of opportunity around where the technology and the physical world start to come together. Customer expectations are high, especially in supply chain. So if you think about supply chain, engineering may be late on a new product introduction. There's issues with labor and staffing and capacity. And so all these things happen that cause them to be late, but it's always like the supply chain people that get blamed. I wouldn't say always blamed, but when I look at the people that are working the weekends, I mean, a lot happens, but a lot falls on supply chain when the parts aren't there. A lot of reasons for it, supplier issues, engineering issues, but it's that buyer that gets blamed, a lot of times because she didn't do the right things. So there's a lot of pressure on supply chain. Because of that, there's also a lot of talent shortages. When we were, going through COVID, I'm sure many of you have dealt with it. The amount of churn that we saw was huge. I mean, we would go into, huge manufacturing companies. We go meet with the supply chain team, and half the team are new. They've been at the company, less than a year. Doesn't mean they're new to the supply chain, but they moved around. So the area of like the talent shortage is becoming a bigger challenge as well. And then, as I mentioned, as well, is that the ability to build product now has become easier and easier. So just quickly on some of the terms around supply chain. So everybody, I think, is familiar with just the broader term of artificial intelligence. And that's really just trying to, automate through technology some of these manual tasks, make decisions more automated. The next area is what we, are called large language models. And just think of that as like an intelligent chatbot, but it understands specific data around demand plans, procurement technology. So in our world, it's not just the LLM. I think many of you have used that, but our focus is how do you bridge the LLM with very deep domain knowledge. So that's called a large language model.
Yeah.
The next area is, another area is called machine learning. And that's where you can look at historical data, start looking for patterns. And I'll give some examples of what we've done around optimizing inventory levels, looking at historical data, PO delivery to identify potential PO delivery risk going forward. So how do we look at and analyze historical patterns and data to predict what's going to happen in the future? And so we've had really good success in supply chain on things like PO delivery risk, inventory actions. Generative AI, if you've gone to some of these tools and asked it to create content, information, documents, that's kind of the area of generative AI, and there's a lot of applications for that. And I don't know if many of you have heard of agentic or, it's kind of agent technology around AI. But what that is, if you think about like workflow engine, which many of you have probably implemented. So it's very similar to a workflow engine, but it links with an LLM. So what ends up happening is instead of the workflow engine just doing a very defined task, it can have a task, but the task can change based on interaction with the LLM. So once it takes a step, it communicates with the LLM based on what happened at that one step. it then gets redirected on what to do next. So think of, agent technology as a combination of workflow with LLM giving direction. And there's a lot of, I would say, buzz around that area right now. So it's hard to know exactly how it's going to evolve, but there's a lot of excitement around that right now. So just some common AI misconceptions. So there's things that we've heard over time, and I kind of summarized 3 points with our view of the world, but just common things that we've heard. One is AI will replace supply chain professionals, and you can apply that to any job. And the good thing, I know you guys are all in manufacturing, and I always use a manufacturing analogy around robotics. Everybody always said, oh, when robotics are going to reduce people, it's going to eliminate jobs. It's like, no, it just means that the jobs are going to change 100%, but it doesn't mean the jobs are eliminated. It just means that now people learn how to program robotics. They're learning how to maintain the robotics, designing the systems. It's just the work changes. So, think of it as it's going to definitely change what people do in a good way, in my opinion, but it's not going to kill jobs. I think it's actually going to create jobs, but it does mean that you need to keep on top of where things are headed, because if you just get left behind and don't really understand where things are changing and what those new jobs look like, that's where you're going to have an issue. But things will definitely change, but it doesn't mean it's going to go away. And in supply chain in particular, I always, feel like the issue today is people just don't have enough time in the day to do the jobs that they need to do. So if this could help people free up their time by automating a lot of the routine activities, and now they can really be more strategic with their suppliers, look at getting the data better, establishing more strategic contracts, working with your suppliers on improvement initiatives, that's really where we want them spending their time, not doing some of the mundane tasks that AI can automate. The next myth we hear is that we need perfect data before starting with AI. You need good data, but the reality is you can start immediately, and we're using AI now to actually help clean our data. So that's one thing. You can start right away. The other thing I would say about data is that it's a never-ending journey with data quality. We've dealt with a lot of companies where they would say, we can't use these technologies. We're not ready. We're excited about it, but we need to go fix our data first. And to some degree, it's true. But then what you find is that it's never quite fixed. So with data, you need to be able to treat it as a continuous improvement cycle. The third myth is AI requires massive upfront investment. And the reality is ROI can be achieved incrementally. Okay, so the key thing is about picking very targeted use cases that are very simple, meaningful to business. And if people are telling you it takes more than weeks, there's an issue. Now, again, that means you have to have some domain knowledge and understand the technology. But we're able to do things in weeks with a handful of people and have real impact on the business. And it's not something that takes years, but it is a matter of picking very targeted use cases to move forward on. So hopefully that's helpful in terms of kind of the AI foundation and what's going on. And I want to hit on 4 use cases that we've implemented. One is around PFEP order policies. The second one is K, which is our AI assistant. Third is around optimizing inventory actions. And the fourth one is around predicting and managing supplier delivery risk to improve on-time delivery. So when we think about the areas of supply chain, there's kind of multiple areas that we go attack. One is inventory optimization. One is shortage management, and another work efficiency. Mm-hmm. And then supplier collaboration. So I'm not going to hit on all these, but PFEP is really focused on the area of inventory optimization. And how do we make sure we have the right foundation? If you look at the way things are done traditionally, it relies upon a lot of fixed rules, statistical calculations. I don't know if anybody has heard of this kind of ABC classification. I'm sure many of you heard of that. But then there's this kind of XYZ classification. So what your ABC classification is looking at where's that, like an A part would be, where's 80% of your daily or monthly spend? That's an A class item. B would be your kind of maybe 15%, that tail, and C are your 5%. And so, this goes back for 30 years. If there's one graph that I would always show, would be this kind of, Pareto analysis showing, look, if we can really optimize that 80%, which is your A items, that's going to have a huge impact on your inventory. You also need to deal with the C items, but you want to think about those in a very different way. And that's what ABC analysis is. XYZ is basically demand variability. It's like, is this part, a very stable part? We use it every day or week. Is it a part that we use sporadically? What does that look like? And so ABC XYZ analysis is looking at, an AX would be like a high spend item that you use every day. It's an X part, so it's very stable. That's a great candidate for, let's say, a Kanban system or a pull system. If it's a C item, very sporadic, we just need to order that when we need it. So ABC XYZ is a way to profile your pattern and characteristics of parts that are then used for how you want to set up your procurement strategy. There's also challenges around lack of simulation. So these are some of the challenges. And so a lot of those traditional challenges just lead to suboptimal calculation. It results in higher inventory, not an effective use of working capital, and a lot of times more shortages. And so a lot of what we did around the PFEP process is really focused on how do you address those challenges. Similar to supply chain maturity curve, we actually created a kind of a sub-component of maturity specifically to PFEP, plan for every part. And the first two areas of the maturity curve is really, whatever policies you're using, and, the policies would be things like order interval, reorder point, Kanban, lot by lot. So the first point is, let's stay with the policies that you're using today, but let's make sure you're adhering to those. Let's make sure that the settings are right. Let's make sure that the safety stock is right. So that's kind of that first phase of that maturity. And let's make sure that, we're compliant with those policies. The idea behind that is, if we're not compliant with our current policies today, it's hard to start introducing new policies. So the next stage of the maturity is actually then introducing new policies. So now that we've optimized the way we're working today, what are those new policies we want to introduce around, let's say we're not using a pull system today, but we want to start introducing it. Let's now start to introduce that from a PFEP process. So the key components of PFEP, one would be around demand analytics. So that's making sure we've got all the correct inputs around, demand pattern classification. We do things like weighting demand profile over time. How do we adjust periods? That's first stage. The next area is around how do we actually want to configure those order policies. So as I mentioned, based on that ABC, XYZ profile, how do we set up the policy and the strategy for each one of those classifications? And keep in mind, PFEP may sound like a very technical, detailed area, but what I would say for any of you running manufacturing or running supply chain, if we don't get this right, it's like your foundation is off. So getting all these policies right is like key for delivery, key for inventory efficiency. The third area is around safety stock optimization, and that's where we want to have much more enhanced rules around how we set safety stock, how we optimize it. When I mentioned earlier some of the work that we did for Airbus around what we call aggregated risk scoring, with safety stock now, we're able to use that aggregated risk score. We can also look at like clear to build and what parts are going to impact production readiness. We bring those two pieces together. Now we can actually score safety stock for each part in terms of what's going to have what part are going to have the biggest impact on risk and production readiness. And then we can use optimization to actually allocate safety stock for those parts that are going to have the biggest impact on production readiness. And so that's some of the new things that we're doing. And then we're able to then simulate that. So now we're able to look at different changes in demand. We're able to look at different policies, different rules. And now we're able to now simulate that to look at what options are going to have the best impact on inventory and service level to give us to the best overall return on the business. And this is kind of, an example of what that would look like. So in this graph here, when I talk about like ABC, XYZ, this is kind of just a view of like a PQ, product quantity analysis. So whenever we start, that's the first thing we want to look at is what are your kind of runners that are those A items at the far left that represent a large amount of your spend. And then as you go to the right, that demand, that kind of average daily demand times price drops down so that the overall spend per month of that particular part are less and less. So the ones on the left would be kind of your A, the ones in the middle are kind of your B, and then you got a long items on the right, which are your C items. What we're also showing in the red or green is, red means you're not at the right inventory level, you're too high or too low. That would be the red. When you're green, it means you're within plus or 15% of the optimal target range that we would expect. And then what you can see there in the numbers is just reflecting what is your kind of current inventory, what is the optimized level, what is the potential savings. So very quickly, when we run the PFEP, we want to get a quick health check, an understanding of where are you today from an inventory perspective, and then where are you potentially could be. As part of this, and again, if you're not doing ABC, XYZ, this may not make as much sense, but what I would describe is like XYZ looks at a very limited number of parameters. So what we did through some of the, AI and some of our analytics, like machine learning in particular, some pattern classification, is we started to look at every single part. We would look at historical patterns of usage. We would look at future patterns of forecast, and we started to classify each part in terms of whether it's a stable part. Is it, variable? Is it intermittent or sporadic? So think of like stable, great candidate for a pull system because I'm using it like every day, every week. Sporadic would be, once every other month, I'm going to buy that part. And so with technology now, and we're talking companies that have 30, 40,000, 50,000 parts, we're able to now classify each one of those parts and then use that strategy for how we want to procure that material and how do we want to set the right order policy. So on the left, I won't read through those. The way we think about it is what are the inputs, what are the outputs we're trying to drive, and then how can that information be used.
Yeah.
We also then have the ability, I have an example here of what I mean by order policy configuration. So ABC is on the left, demand profile is on the top. And so what I was kind of reflecting here is that if I have an A item, 80% of my spend, stable, I'm able to now go in and configure exactly how I want to manage that part based on that classification. The other thing you'll see here at the top is we've introduced kind of a third dimension of a traditional kind of ABC, XYZ classification, which is lead time. So now we can not only say that this is an A item that's stable, we can also say, and it's got a short lead time. Let's put that on a, reorder point. But if it's an A item that's stable, but it has a long lead time, I may want to put that on pull, but I want to use like a min-max where I want to use a min days coverage of 10 days and a max days coverage of 20. So you're able to very strategically start to look at this data now based on the analytics and start to think through, well, how do I want to manage that part? Our system will recommend this to you, but the user can then take the recommendations or make changes. And so it may be a little bit hard for you guys to read it, but as I click on it, what you're defining here is it's asking you what is the right triggering method you want to use. Again, it will make a recommendation, but you can choose, I want to use average daily demand times lead time as my trigger, or I want to use a trigger based on min days quantity. You can then define, well, okay, that's my trigger. Now, what do I want to use for my order quantity? Do I want to order an EOQ? Do I want to order 80, demand times lead time? Do I want to take the maximum of my MOQ and my EOQ? There's different rules you can use. And then you finally can choose, how do I want to set the safety stock? So the combination of all these things ultimately come up with a target inventory per part that adds what we call safety stock. It adds in cycle stock, which is based on the policy. And then ultimately it gives us kind of that target level of inventory. And then based on that, what you can see here on the right is probably a little bit hard to read, but this axis is your target optimized inventory level. The bottom right is service level. And then these are every simulation run that I've run. So I can change my rule for safety stock. How did it perform based on inventory and service level and delivery? The size of the dot varies based on delivery. I want to implement a new demand-driven strategy like Kanban. One of the concerns people have is that that's going to hurt our service levels potentially. Even though people that have done a pull system and have done it well, you know that it doesn't, but people that are new to it get concerned about it. So now we're able to simulate different profiles and look at the performance of those and help build their confidence in terms of simulation. We've also had companies that said, but I still don't understand, like, show me for a particular part. And then manually, they were taking part by part and trying to do a manual simulation of how, let's say, a Kanban or an order interval system would perform over time. So what this is doing is it's showing a single part that we simulated over time, with the green bar being the target optimized level that we calculated. It's now looking at supplier delivery performance, lead time demand variability, different characteristics of the future demand, and it simulates how that system would perform over time. And so we use this a lot just to build confidence with the recommendations that our system is able to make. Each of these are when we trigger a PO. This is when the PO comes in, and it's just showing that. And we can do that for like a Kanban part, a reorder point part, just to show people how it would perform. And I'll go through this a little bit. I'll just bring this up. But the other thing I just want to put here is, I'll just let you read it, but there's 4 components of the readiness checklist. It's data systems, culture, business case, and technical readiness. So it's real important as you think about like where to start and what are the characteristics you want to look for. Most of these are pretty straightforward to achieve, but you definitely want to think about it. And don't think about your whole company. Think about it from the perspective of a very targeted use case. Again, we don't need all the data, but if for this particular use case, do we have these elements in place? Do we have the team involved to work with this area? And that's a good opportunity for readiness. So the next area is just K, and just to read this real quick. So we have an AI, and so I'm able to demo this. But my question was, it just says, hello, my name is Kay. I'm here to help you understand your inventory analysis. What would you like to know? And I just asked the question is, what are the top 10 items that are having the most critical impact on CTB? And no LM would normally know what CTB is, but we've trained it to know that stands for clear to build. And so our question was, we're doing all this analysis, but tell me what are the 10 parts that are having the biggest impact on clear to build. And then Kay responded, to determine the top 10 items with the most critical impact on clear to build, CTB, I'll analyze the data based on clear to build impacted orders, which is, again, it's a concept and a metric that we introduced, which is, not only what is the parts impact your ability to ship, and which is clear to build, but what's the value of that order? And maybe some orders are very expensive, some are less expensive. What are those materials that are impacting your clear to build? And so now Kay is able to give us like each individual part number, the impacted orders that are affected by it, and what's the value of it? I then asked the question is, who are the suppliers that are causing the biggest impact on shortages and excess inventory? Very, abstract, but now it's able to give us like the European controls, highest number of CTB impacted orders, 107, clear to build and shortage impacted value, around 8 million total shortages occurrences. So it's actually looking at historical data, looking at forward data. So the key thing is you can do a lot with these AI technologies, but you've got to train it on your data. And then the last question is, can you review my safety stock configuration for ABC XYZ demand profile, service level, and settings, and let me know how I should make any changes. So this was an example where we actually wanted Kay to go look at all the parameters and how we set up our policies and let it tell us what we should change. Like take your AX items and make the service level 97%. This should be 95%. And this is kind of what's exciting about AI is that this is almost like for an analyst, he's got this kind of assistant sitting next to him that understands the data, understands supply chain, understands our math, our models, our calculation, and now it becomes very valuable. What you want to avoid with all this ChatGPT, because people will get excited about it, is that if you just ask it questions, it's called hallucination. It'll just generate a lot of garbage information. So the key thing is you got to be really thoughtful in the use cases. You got to be thoughtful in the data. And then based on that, as you can see here, it becomes incredibly valuable. I mean, we're very excited about it. The other use of AI that we do is around inventory actions. And this is just called a burn-off chart where to the left of, you can't really see it here, but this is today. We track historical performance. And then the blue line is our system telling you this is the potential you can get to over time. This is your potential inventory level. The orange line says when we look at everything in your ERP system from planning, forecasted orders, incoming supply, PRs that are being generated, all your order policies, triggers, this orange line is what you're going to do, but we think this is what you can do. And then based on that gap, our system then says, okay, these are the parts you need to go action that are the biggest driver of that inventory opportunity gap. And then based on that, you can then drill down and actually understand, the recommendations, why it's making the recommendation. And what I want to highlight here, why PFEP is so important is this green line here is what is established through our PFEP process. So our system is identifying what's the right target level. And then from an execution now, we're able to identify the opportunity, what's the gap, what are the parts driving the gap, and then trigger these actions and have the agent go drive it. That's now going to help us close that gap, but in a very strategic way, right? It's not just taking MRP data or ERP data and very generically, it's very targeted level, targeted actions. We prioritize that. And then we drive those actions to closure. And then we can also monitor over time, well, but what did we recommend 3 months ago? Well, this is what we recommended 3 months ago, or not recommended, but this is what was going to happen 3 months ago. This is what we recommended and what we could drive actions to. And this is what we're able to achieve. So this gets in that reinforcement learning, right? If we made good recommendations, let's do more of it. If we made bad recommendations, let's understand why and let's correct. So it really combines optimization with execution. And then the last thing I'll just hit on real quick is supplier risk. So this is using machine learning to look at past supplier performance. And when we have a PO that we need to, let's say, expedite because it's going to cause shortages, we can identify that, but we can also flag ones that we think that even the commitment that they're making, we think there's a risk to that based on historical performance and many factors, so we can tag that. And then this is that example I mentioned earlier where we can use aggregated risk scoring to help us service up critical shortages. We also, for those of you, again, in manufacturing that are using lead time, every ERP system has one value for lead time. Here's my lead time for this part. The reality is it's much more dynamic. So we have the ability to look at actual demonstrated lead time and then actually mathematically start to look at what's relevant, what's not, and start to understand what is the actual true demonstrated lead time for this particular part. And just quickly on the future, I know we're running short on time, I'll leave some time for Q&A, but we try to think of it as like next 6 months, 6 to 18 months, 2 to 3 years. Most of what we're doing today are things that obviously we think are coming out the next 6 months. There's a lot more coming out over the next 6 to 18 months around more analytics. I think over the next 2 to 3 years, what we're excited about is more where you start to have AI talking to AI. And just quickly on that use case here, this is where, if you think about on the right where you've got your tier one factory, one factory, and then they have another supplier to that, but that's basically a factory too. The opportunity is where you have clear to build that's identifying a critical shortage. And instead of it going to an individual, it's talking to another AI. So one system is saying, hey, I need this part. It's an aggregated risk score of 40, critical to clear to build. It's representing $8 million of orders. I need you to expedite that. Can you meet this delivery? That's clear to build. Then through Supplier Connect, it's talking to another factory, and we want that agent to now respond, yeah, I can do that or not. And for it to do that, it understands the same information, but it's now kind of this, planner is trying to deal with one aspect of the factory. It's communicating with Supplier Connect, talking to another system. And then you can imagine over time, the supply chain now becomes this connection of factory to factory. And I'll end with this, but where I get excited with where a lot of this is headed is supply chain is a lot of distribution, warehousing. There's so many aspects of supply chain. But if you can create this kind of factory connectivity with prioritization, it kind of changes the world, because now there's a lot less waste, which is core to Lean, because now everything is much more synchronized. So warehouses, distributions is really a reflection of that. The factory can't ship direct, it can't ship or as direct. And the more it can be shipping direct or more accurate in a prioritized way to its consumer, which could be a factory or it could be a customer, the more that becomes more prioritized, more direct, a lot of the waste gets eliminated. And that's kind of what gets excited.